So previously we've been looking at specifically right triangles and how the trig functions apply to those, but now we're going to be looking at how we can generalize those laws to triangles that might not necessarily have right angles associated with them. So let's just kind of draw a general triangle here, just to remind you how we label the angles and sides. We call this angle A, angle B, and angle C. The side opposite of A we'll call lowercase a, and then the side opposite of B we'll call lowercase b, and etc. The side opposite C we'll call lowercase c. So that's how I would define my general triangle, and this even works for right triangles as well, but we want to come up with an overall law. So the law states that the ratio of the sine of angle A, and this is the law of sines, by the way. The sine of angle A divided by the length of side A is equal to uh, the ratio of sine of B over side B, and both of these ratios are equal to sine of C over side C. So let's look at how this would apply to an example. We're given the side lowercase l over here, and we want to find, in other words, we want to solve this triangle. So we want to find side n, side m, and angle n. So first of all, angle n should be relatively easy to solve using some geometry principles. You know that all three of these angles have to add up to 180. So 112 plus 29 plus some other angle, which obviously is n, is going to equal to 180. So 112 plus 129 is 141, plus n is 180. And then when we subtract, n is going to be equal to 39 degrees. So this angle now we know is 39 degrees. Now that's going to help us find side m and side n. So remember, when we use our ratios for the laws of sine, the sine of the uppercase angle, so such as m, would be 112. That goes over little m. We know the side 22 over here, and we also know the angle 29 for L. So that's going to be a ratio that we're familiar with, and that's going to be the smartest ratio to set this up with. So the sine of 29 is going to go with the side of 22. So when we cross multiply those, sine, or 22, I should say, sine of 112 equals m times sine of 29. I'll go ahead and divide both sides by sine of 29. So then I get that m is equal to whatever the value of 22 sine of 112 is divided by sine of 29. So bringing up my calculator, when I put that in, 22 times the sine of 112, make sure you're in degrees, divided by sine of 29, I get 29.5 for my side length of m. And now we've got the 39 degrees, we've got 29.5. The only thing left is the side length of n. And now we can use either side to help us out. We might as well just keep going with the ratio. Sine of 29 over 22 is equal to the sine of sine of capital N, which is 39, over the side of lowercase n. When I cross multiply those, I get n sine of 29 is equal to 22 sine of 39. So then to solve for n, I'll divide both sides by sine of 29. So I get that n is equal to 22 sine of 39 over sine of 29. And I get I apologize. It appears I am actually in radians, and I even said to make sure that you weren't in radians, but let's try this one again real quick. 22 sine of 39 over sine of 29. The actual value should be 28.6, and I was actually in radians for the previous calculation, so let me undo that. So let's try that one more time as well. Let me see if I can get that entry. There we go. So sine 112, 22 sine 112 over sine of 29 is actually 42.0. And so that should be your answer, not the previous answer, which was in fact in radians. So that's how you would use the law of sines to solve a triangle. So here's an example you can try on your own. See if you can solve triangle XYZ.